Right, Assalamualaikum, selamat petang.
Waalaikumsalam, sir.
Okay, last week we have discussed about neuromotor. So this week we are going to continue regarding motor control theory. So in this topic we are going to discuss a bit about how our mind, okay, how the CNS, the Central Executive yang paling atas sekali tu, how our mind determine what kind of movement we are going to conduct and how it become like that. Kenapa, apa action and kenapa. Okay, so in order to answer those questions, there are several motor control theories that you need to have in mind. Okay, so before we start, this is the what we call it, the definition of theory. Okay, so theory can be defined as a large class of observation. Okay, in other words, we can say theory is something that in terms of observation being made regarding something. Okay, satu observation tentang sesuatu where the outcome of the observation always similar. Contoh ni macam ni. Teori kata manusia tak boleh terbang. Contoh. Why? Because every time manusia lompat pada tempat tinggi, they are going to fall down. They are not going to gliding. Itu teori. Okay, teori said that if you take enough sugar, you can have a better performance. Teori said. Jadi kita kena provekan teori. Okay, maksudnya based on the theory ataupun based on the prediction, and this prediction is based on a lot of observation. We can come up with one outcome. Itu maksud teori. Okay, accurately describe a large class of observation. Accurately describe. Theory said that if we use lighter shoes, we able to run faster. Okay, so afterwards we are going to test lah. Itu maksud teori. Okay, ataupun apa lagi? Teori apa lagi jenis teori? Apa lagi teori What kind? Theoretically speaking, everybody can walk. Theory. Okay, theoretically speaking, but some of them still cannot walk. Cuma when we talk about theory, the thing that being said is true towards a larger number of observation. Itu teori. Okay, ataupun yang ni, teori mengatakan siapa yang landing dekat bulan yang pertama tu, Neil Armstrong is the first astronaut who land on the moon. That is theory. Okay, that is theory. Whether it is true or not, kena test. Okay, kena test, because if we talk about truth, the first that land on the moon is not Neil Armstrong. Ada orang sebelum Neil Armstrong dah land on the moon. Okay, tu masuk teori. It means that a statement, a term that accurately describe about something, some phenomenon. Okay, some phenomenon. And this term is being accepted widely. That is the meaning of theory. Okay, so theory also make definite prediction about result of future observation. When we make a theory, this theory can be used before, during, and after that particular time. It still serve the same. Itu maksud teori lah. Okay. So in motor control, we have several theory which explain about why our movement happen to be like that. Okay, and all of those motor control theory serve to answer two major issue. One is coordination, another one is degree of freedom. Okay, so describe and explain how the nervous system produce coordinated movement of motor skill in a variety of environment. They describe how our CNS control that movement. And how our CNS solve these two problems: coordination, degree of freedom. Coordination is coordination between body parts lah. For example, we try to write. Okay, we try to write. So we have a coordination between our fingers, our hand, and eyes in order to ensure that the writing is good. Okay, for example macam ni. Yap. Okay. I need you to get a piece of paper, just a blank paper. Okay, semua orang dapatkan satu paper and I need you to draw this. 1, 2, 3, 4. Okay, I need you to draw this one. Okay, next. Afterwards, I need you to make a shape. Okay, I need you to make a square shape. On the first box, I need you to draw a square. You start from left hand side to the right, bottom, left, and up, as smooth as possible. Okay. On the second box, the same thing, but now, instead of going to the right, we are going to switch side. So I need you to go to the left. Left, bottom, right, up. Okay. The third one, we are going to conduct as similar as number 1, but now I need you to close your eyes. Okay, letak and close your eyes. Go to the right, bottom, left, and up. Lepas tu buka mata. Okay, for the fourth one, we start from the right, but again, in this condition, please close your eyes. So go to the left, bottom, right, and up. Tak ada. Bottom, right, and up. Okay. Able to do this? Dapat tak gambar yang macam ni? Do you have this one?
Dapat, sir.
Bentuk dia okey tak?
Tak berapa nak okey, sir.
Okay. Now, yang kedua. 4 lagi. Now, instead of doing a square, we try to do a circle. Okay, circle yang ni kita ke kanan. Circle. Circle yang ni kita ke kiri. Circle. Circle yang ni kita ke kanan. Tutup mata. Tutup mata. Circle. Okay tu. Circle yang ni ke kiri. Tutup mata. Video. Circle. Okay. Yang kedua. Yang ketiga. Page yang ketiga. Sama juga. 4. Now, we do with our non-dominant hand. Kiri. Okay. Yang pertama, okay, kotak ke kiri. We go left, bottom, right, top. Kotak yang kedua, we go to the right, right, bottom, left, top, to the right. Kotak ketiga, we go to the left, but now with a closed eye. Closed eye, left, bottom, right, top. Yeah, road. And this one to the right, uh, tutup mata, right, bottom, left, up, right. And for box number 4, for the fourth page, with non-dominant hand, we are going to conduct a circle. Petak pun mengarut buat circle. Circle. Aduh, okay, circle to the left. Circle. Wih, dah macam amoeba. Okay. Circle to the right. Close eye. Okay, close eye. Circle. Circle to the left. Close eye. Circle. Ngagut weh, ngagut. Macam mana hasil?
Seni itu berat.
So yang ni yang pertama tadi will be dominant hand. Square. Okay. Yang kedua ni dominant hand. Circle. Yang ketiga non-dominant hand. Square. Yang keempat non-dominant hand. Circle. Ada nampak perubahan tak? Means daripada lawa jadi buruk tu dah tentulah. Ada tak based on trial dia dapat daripada lawa jadi buruk jadi hampir-hampir lawa balik? Saya punya ni memang buruk terus lah. This is number 4. Ni number 4.5 kot. Petak pun jadi macam amoeba. Macam mana? Buka mata pun tak petak. Okay. So our mind, based on the theory, it start to develop some of the let's say some of the way in order to overcome problems. Okay, one of the problem is coordination. Macam ni lah. Okay, kalau kamu tengok ni kan, kita tengok yang pertama. Open eyes, close eyes. Okay, how can you see your own? How can some of you macam saya kan, open eyes is much worse compared to the closed eyes. Ada tak yang nampak macam ni? Ada apa yang open eyes dia tak cantik, closed eye dia lagi cantik.
Ui, jarang-jarang berlaku tu.
Ada sir.
Mesti ada, because some of you will start to you close your eyes. Yes, that's true, but instead of using eyes, now you're using senses dekat tangan. You sense the placement of the hand in order to make it quite square. Tapi circle susah lah. Means if you lost one part or you lost a sensory, your body is going to rely on to another in order to solve the problem, the same problem, which is drawing. That is the first issue being discussed under motor control theory. Coordination. So how your mind control the coordination of the body is by using sensory. Okay, and which sensory being turned on, which sensory being turned off will determine the outcome. And if the sensory that need to be on suddenly off on that particular time, your body is going to rely on another one. Nanti kita akan tengok teori apa tu. Okay, number 2, your body throughout the lifespan will start to solve the problem of DOF, degree of freedom. Ni dua masalah utama yang CNS settlekan. Degree of freedom. Okay, degree of freedom ni macam ni. Macam ini, macam ini. This is degree of freedom. Siapa kaki main game dengan kaki main remote control, dia senang sikit nak faham. Okay. Padam dulu, menatang-menatang mengagut ni. Subjek lain ni. Right. Um, Siapa yang pernah main helicopter control? Do you ever come across playing with remote?
Saya pernah.
Benar.
Yes sir.
Senang, susah ke senang?
Susah.
Susah.
Okay, kamu main berapa channel?
Hmm,
Helikopter tu dia ada beberapa model. Dia ada yang 4 channel, dia ada yang 6 channel. Selalu bila beli dia ada tulis 6 channel. Okay, dia macam ni. Kita tengok pada atas If we observe our helicopter from above, 4 channel able you to do like this. Turn, 1, turn, 2, and then go forward, 3, go backward, 4. Maksudnya kalau kita tengok pada tepi, heli tu boleh bergerak ke depan macam ni, ataupun dia bang ke belakang. Ni 1, 2. And then dia boleh rotate ke kiri ke kanan, 4. Kalau 6 channel, kita boleh leaning. Sengit ke kiri, sengit ke kanan. Tu 6 channel. Okay.
faham.
Lagi satu, kita ada helikopter yang boleh buat 3D. Dia boleh terbalik. Kaki kipas kat bawah, badan dia kat atas.
Uyu.
Ni yang orang buat akrobatik. Maksudnya, we can change the direction of the blade spinning. Because RC heli, kan dia punya kipas tu kan. Ada yang ada 2 level kipas, ada yang ada 1 level kipas, dia ada kipas kat belakang. Okay, apa yang sebenarnya terjadi? It push down air. Itu je yang dia boleh buat. And why it push down air? Because dia nak dapat lifting up. Okay, bila helikopter yang boleh terbalik macam ni, dia boleh nampak contoh-contoh dengan heli kan, dia boleh fly macam ni je. Means dia boleh fly ke atas tapi kipas dia ke bawah. Meaning instead of pushing down air, dia boleh push up. Change the direction of the blade. So yang ini dia dah lebih pada 6 channel, dia acrobatic, it can change. So the difference is, kalau kita tengok dekat controller, okay, kita ada tombol macam ni kan. Kalau yang 4 channel, it can be push up, push down. Okay, sebelah sini pun dia boleh push left, push right. 4 bahagian. Kalau 6 channel, apa yang akan terjadi is sebelah sini pun ada push left and push right. Untuk yang acrobatic, we have all 8. And then another button in order to reverse the blade of the rotation of the blade. Okay, this is what we call degree of freedom. Okay, meaning throughout our lifespan, our number of ability to move going to expand. Mungkin dulu kita punya pergerakan boleh ke depan, ke belakang. So our mind just control forward and backward. And then we can go sideways. Pergi kiri, pergi kanan. Okay. Then we can go diagonally. Boleh pula ada macam ni. Manusia kan pergerakan. Nah kita dah ada 8. Okay, kita dah ada 8. So 8 is too much. Okay, it is too much. Okay. Imagine this one. If you have this 8 direction of movement, 1, 2, 3, 4, 5, 6, 7, 8. And to execute every single movement, your mind need to have one plan. Okay, nak bergerak ke depan, button nombor 1. Nak bergerak ke tepi, button nombor 2. Okay. And try to imagine maximum number of button a mind have is 10. Ni maximum. Kita dah guna 8 dah. So you may have extra 2 je. Mungkin satu tu melompat. Satu lagi meniarap. Ni je yang kamu boleh buat. So macam mana nak memanjat? Macam mana nak menerjun tiruk? Okay, meaning that there are still movement which you cannot do because of limited degree of freedom. So what happened is your mind going to change the degree of freedom. Going to adapt. Okay, so how adaptation occurs? is something like this. Instead of using 8 buttons to solve this problem, they are going to reduce this 8 button CNSly to 4. So how they do that? They come up with not a simplification lah. They come up with a way to overcome that by installing 2 buttons. Okay, button apa dia install? Button A, button B dalam otak kita. So apa button A buat? Bila dia install button A, all straight instruction will be activated. Maksudnya, kita sekarang hanya ada 4 sahaja arahan. Arahan 1, arahan 2, arahan 3, arahan 4. Okay, and this will be button yang kelima. So, bila dia nak gunakan arahan yang triangle, dia akan aktifkan button ke-6. Automatically, 1 akan jadi diagonal kanan. 2 akan jadi diagonal kanan bawah. 3 akan jadi diagonal kanan, diagonal kiri bawah, dan 4 akan jadi diagonal kanan atas. Along the way, for every action, only 5 different button being used. Means you may have another 5 for others. Dah boleh dah melompat menyerap, dah boleh tambah 3 lagi. Because there are spare button. This is degree of freedom. Okay, maksudnya our mind will start to come up with ways to overcome that problem. Okay, saya bagi contoh lagu satu lah. I give you another example. In term of degree of freedom. Okay. Kita ambil crane. We take crane. Okay. Kita ambil crane. Crane yang selalu duduk belakang lori tu. Dia tinggi. Lepas tu dia akan ambil tali cangkuk. Alright. Now, this is from sagittal view. Kalau kita tengok daripada transverse. Okay, tengok pada atas. So, something like this. And we have the boom. Okay. Katalah pergerakan yang dia boleh buat. 1 is rotate. 1, 2, rotate. Lepas tu, angkat. 3, 4. And then, gulung. Okay, gulung tali ni. 5, 6. And then, memanjang memindik. 7, 8. Betul, 8. 8. This is the action that can be done. 1, 2, 3, 4, 5, 6, 7, 8. Okay, if you go inside the cockpit of this machinery, you are going to see buttons like this. Crane control. Okay, ini yang kedua. Kita nak cari yang zaman kuno punya. Kuno. Ada lah. Analog. Crane control. Can we have it? Ini masih lagi apa ni? Masih lagi baru. Kita cuba untuk cari yang lama punya. Bila kita masuk sini backhoe crane control. Okay, this one. Ni lah. Okay. Alright. So, previously, crane control is something like this. They use analog control. Okay. What being done by here is every single stick here control two movement. Contoh kita ambil contoh lah. Kita ambil contoh based on here. Aju pula dia pergi. Based on here. So, to move left and right, they need to use satu. Tolak depan, dia pergi kanan. Tarik belakang, dia pergi kiri. This is the problem of degree of freedom. Okay, yang kedua, in order to make the boomstick move up and down, dia akan guna yang kedua. Up and down. Yang ketiga, to roll the spool long and short, dia guna yang ketiga. Long and short. Yang keempat, to extend the boom. Pergi ke depan, pergi ke belakang. They use extending. Depan dan belakang. Okay, so dia ada satu lagi ni. Ni untuk apa ni? Telescopic loafing. Dia boleh move tengkuk ni boleh bergerak dua hala. Yang ni boleh bergerak macam ni. Yang ni boleh bergerak macam ni. Jadi pergerakan tu gunakan yang terakhir. So to do every single action, you need to use different level. Satu untuk pusing, satu untuk tali, satu untuk extending boom, satu untuk bring raise up or raise down the boom, another one to patahkan dia. Contoh patahkan dia punya boom. So, in order to control one particular boom, you need to use 5. Tapi tangan ada 2 je. Jadi bila kita buat yang ni, kita tak boleh buat yang ni. Bila kita buat yang ni, kita tak boleh buat yang ni. Bila kita buat yang ni, tak boleh buat yang ni. We can use only 2 level at one time. So to solve this problem, this is degree of freedom. Means at one particular moment of time, we can only use 2 based on the hand. We cannot use all 5. So to solve this one, they come up with much sophisticated control. Ataupun they use a joystick. Where this joystick able to control, satu joystick ni able to control more than 4. It can go front, it can go back, it can go sideways. Before we start to twitching with the buttons. Do we have buttons here? No. Buttons. Kalau kita tak tekan buttons, kita tolak ke depan, boom move forward. But when we push button, we push forward and then dia bukan lagi boom move forward, but dia mungkin turunkan tali. So now one hand can control 5. Ni maksud degree of freedom. So throughout the lifespan of our life, our CNS do this thing of do this kind of thing. They make movement simplified and make you or enable you to have much sophisticated movement throughout the lifespan. Dulu tak boleh, sekarang boleh. Because of degree of freedom. So, ni contoh paling mudah lah. Twirl lever dengan pakai joystick. So, dekat sini je 1, 2, 3, 4, 5, 6. Pergerakan ni boleh pergi 4 hala. So, one joystick can control 24 different movement. Okay, so setiap satu ni can go 4 way. Button nombor 2 can go 4 way. Button nombor 3 can go 4 way. So, total up 24 movement by one joystick. This one 10 movement by 5 joystick. That is the degree of freedom. Okay, macam tu. Tu degree of freedom. Okay. Kalau macam dulu kita main Mario kan, nak lari kena tekan button B. Nak lompat kena tekan button A. Nak jalan kena tekan joystick. So, at every single point of time, you may control 3 button. But now, when you have turbo button, nak lari, tekan satu button dah boleh lari dah. That is issue of degree of freedom. Ni. So our CNS solve these 2 problem. 1, coordination based on sensory. Number 2, degree of freedom. So that you may have much refined movement. Okay, itu dia. Teori dia. Right. So this is the coordination, the definition of it. Patterning of body and limb motion relative to the patterning of the environmental object and event. Maksudnya we able to put our body parts or limb in use. Contoh, kalau bola, kita nak kejar bola. So we can we can differentiate children and then adults in order to receive a ball. So adults is much more easier in order to anticipate. Kita panggil anticipate where the ball go, and you can go there. Coordination. But children, they anticipate juga, but the anticipation does not solve the problem. Most of the time, the ball is going to pass them because they cannot coordinate their body. They cannot put their body in use. They don't have the speed. To issue coordination. Okay. And number 2 is degree of freedom. How does the nervous system control a given pattern? Macam tadi lah, whether the control is one by one or they can merge up everything into one and only use one control. Okay, sampai sini dulu. Boleh faham? Can you
Okay,
understand?
teacher.
Boleh
Okay, boleh.
Okay. So
Okay, sir.
our mind solve degree of freedom and coordination problem by using two different loop system. Okay. The differences is just whether you have feedback ataupun tidak. Okay, you have feedback ataupun tidak. So movement control center is your central executive, is your mind. It will send out instruction to conduct a certain action. Okay, and that instruction will be sent to motor, to muscles. Okay, here we have feedback. Here we don't have feedback, meaning it starts from the central executive, it ends at the motor, regardless of the outcome. Regardless of the outcome. Contohnya, kita nak sepak bola, so kita pun sepak, kena tak kena, lain cerita. But here, we have feedback. Means, based on the movement effector, based on kaki tadi, we can determine the ball is not going to be hit. Why? Our eye sense it is not in the right place. So, feedback being given, you need to move forward. And then, you get a hit. Itu contoh dia. Without feedback, with feedback. So, kalau without feedback, kita panggil sebagai open loop lah, since dia terbuka. Okay, closed loop, we have feedback, meaning there will be modification. This one, there won't be any modification. So, action yang ini selalu kita guna pakai dekat open skill ke closed skill? Open ke close? Open ke close? Ni topik nombor 1 dulu ni. How we classify motion. Open skill, closed skill. So, closed skill mainly use open loop system because they don't need feedback in order to perfect the action. Such as tee off. Such as archery shooting. Buat benda sama je. Okay. But sometimes, adjustment need to be made. Barulah dia masuk kepada closed loop. So, most of the open skill is in here. Because you need to conduct an action based on what happened in the surrounding. Okay, so closed loop, open loop, most of the time being used for closed skill. Closed loop, most of the time being used for open skill, where we need to have feedback in order to execute the skill as best as possible. Ini adalah dua jenis sistem. Okay, the difference is just towards whether you have feedback or you don't have any feedback. Okay, this is system in in making movement. Okay, so open loop does not use feedback. Central control center provide all the information, meaning dia akan guna je information yang diberikan. However, closed loop, they use feedback. Control center send information to the to initiate. Okay, to initiate, and there may be some modification made in between sending to executing because of the surrounding. Tu beza close dengan open loop. Okay. Alright, sampai situ dulu. Soalan. Ni teori dia. Tadi dua je teori dia. Any question? Before we go to theory. Soalan? Any soalan?
Tak ada saya.
Nggak ada. Okay. So next one is teori. Ni dua teori yang menceritakan tentang how our motion being produced. Okay. It is known, the first one known as motor program based theory. And number 2, dynamic pattern theory. Okay, motor program based theory and dynamic pattern theory. Kalau ikut nama dia, beza dia satu je. Dynamic ada dynamic, motor program tak ada. Meaning this one is constant. Okay, we go to the first one. Motor program based theory is hierarchical oriented theory. Solve the degree of freedom problem through the motor program. Motor program is a memory based construct, control coordinated, and it is proposed by Smith. That generalized motor program control class of action versus specific movement. So Smith generalized motor program. After this, we are going to call motor program ni sebagai GMP. Okay, GMP. Generalized motor program. Control a class of action. A class of action contain invariant features and parameters. Invariant features are fixed and do not vary. Parameters added to variant features enable performer to meet specific demand. Okay. Alright. So, apa itu? Smith schemata ataupun GMP. Okay, contoh. Okay, contoh dia macam ni. Kita masuk kepada teori yang pertama. Teori Darwin. Okay, GMP ni, you imagine something like this. In our mind, ni kita punya otak, there are a lot of cupboard. And this cupboard contain file of movement. Okay, and this file of movement is known as generalized motor program. Folder. Okay, dalam satu folder melibatkan satu class of action. Okay. So in every single GMP, saya namakan sebagai GMP1. Okay. In every single GMP, there are multiple subfolder. One is for invariant features. Another one is for parameter. Okay. These two serve for only one class, GMP1. So kelas lain GMP2 lah maksudnya. GMP2. Okay. Contoh, what does it mean by one class of action? Okay. Let's take walking versus jogging. Apa beza dia antara dua ni? Walking, jogging. Walking, jogging. Apa beza? Between
Cepat atau lambat.
cepat atau lambat. That is the difference. Meaning speed lah
The speed, yes.
Okay, speed is the difference. Alright. Now, let's take a look. What is invariant features? Form the basis of what is stored in memory. Two common invariant features are relative timing, relative force. Parameters, specific movement features that can vary from one performance of a skill to another. Specific movement features. Okay, so this is one of the movement features, speed. Jadi, speed akan diletak di sini. Apa lagi berbeza antara walking dengan jogging?
Langkah dia, sir.
Stride length. Okay,
Yes.
lagi? Satu lagi je, kita ambil sikit lah. Sama je contoh dia nanti. Satu lagi. The difference between walking and jogging. Except for the spelling lah.
The time untuk sampai sesuatu tempat.
Tak, itu depends. Itu depends.
Oh, itu depends.
Itu depends pada laju kamu, speed tadi. Ini in term of action of walking and
Dia
jogging,
punya
what is the difference?
pergerakan kaki tu.
Ah,
Maybe ada lain sebab jogging kan nak kena angkat kaki sikit kan.
Okay, so kita namakan dia sebagai apa? Lift up. Leg lift up. Something like that. Lift up lah
Ya.
Okay. Now, apa yang sama? Dua-dua apa? Move forward.
Maju ke hadapan.
Okay, maju ke depan. Lagi? Apa yang sama? Apa yang sama? Kerja sama. Move forward. Move forward. Walking and jogging. Apa lagi? We have leg and hand swing.
Yes.
Okay, lagi? Satu lagi. Satu lagi yang sama. Apa dia? Berjalan dengan berjogging. Cuba fikir, apa yang sama berjalan dengan berjogging? Tangan berayun, kaki berayun. Yes, that's true. Dua-dua bergerak ke hadapan. Yes. Another one. In term of shape dia, macam mana kita explain shape dia? Ada body straight or are you going to leaning forward? Cuma nak berlari kan? Ke tegak? Which one? Oh yeah, man, come on. This is class, not a cemetery. Body straight.
Body position.
Okay. Sekarang kita dah ada 3 benda yang sama, 3 benda yang lain. So in this GMP, okay, we call it as GMP 1 or maybe we call it as GMP 1 is for forward locomotion. Forward locomotion. Okay. So based on Smith schemata, it said that in our mind, a GMP will be produced for one class of action. One class. Maksudnya berjalan ke hadapan is one class. Berlari is still one class. Melompat ada lain. Ataupun sepak bola, that is different class. Okay. So one class of action, most of the time, it share the same kinematic. Share the same pattern. The movement share same pattern, but maybe the difference is just towards the speed. Towards apa lagi? Benda-benda macam tu lah. Dia ada beza, cuma bentuk dia sama. If we observe people walking and jogging, the shape is similar. Tak ada pula orang jogging pakai 4 kaki kan, itu maksud dia. If people jog with four peripheral and then it is not in one class because walking only use leg, don't use hand. Tu benda kena faham benda yang pertama. So they make a GMP for every class of action. Berjalan ada GMP, makan ada GMP, manipulating with hand, there are GMP, manipulating object with leg, there are GMP, climbing, there are GMP. Dia tu dalam kepala kita. And this GMP, every single GMP store 2 subfolder. One is known for invariant features, features that does not change. Mungkin kita namakan dia sebagai IV. That's IV pula, IF, invariant features. And another folder is the parameter. Okay, this parameter enable our mind to determine what action that actually want to be executed. Okay, contohnya we have the first one is speed. So kita ada 2. Kita ada folder P1, kita ada folder bukan P1, kita namakan sebagai S lah, speed kan. S1 and S2. S1 medium speed, S2 low speed. Okay, stride length kita ada L1 dengan L2. L1 long ataupun medium. L2 short length. Okay, and then kita ada lift up. U1, U2. So U1 is high, U2 is low. Okay, when we try to execute a movement of walking, our mind will load this file. Jadi dia akan load apa? Dia akan load GMP forward locomotion, and underneath this dia akan load IF, and dalam P dia akan load S2, L2, U2, resulting you are going to walk. Ni based on GMP. Okay, based on generalized motor program. So it said that every class of action there are generalized motor program. In order to differentiate several movement within the same class, the parameter will determine that. Okay, jadi dia akan buat satu GMP and all action which have similar invariant features will be put underneath those GMP. Ini teori yang pertama. Okay, this is the first theory. Basically, those two theory is complementing each others. Cuma kita nak kena faham satu-satu. So, teori ni kata, kalau kita nak berjalan, this will be the GMP lah. Katalah kita nak berlari. Our mind will load GMP, forward locomotion, invariant features, and for parameters, dia akan load S1, L1, U1. So, you end up dengan jogging. This is based on Smith schemata. So, we have a lot of GMP based on class of action. Ni adalah apa yang Smith katakan. So, people will always ask, what about the changes? Dulu kita lari lambat, sekarang kita lari laju. Meaning, there will be some change towards parameters. Meaning that your parameter subfile will be keep on updating. So, you're going to have more and more choices throughout the lifespan. Whenever you encounter that particular problem, a new GMP will be produced in order to overcome that. So that in future, when you face the same problem, it is not hard for you to do so because you have the GMP to overcome that. Contoh kita tengah berlari, ada longkang. Lompatan kali pertama masuk longkang. Lompatan kali kedua tak ada dah. You're going to over that particular longkang because now you have the refined GMP. Ini cerita generalized motor program. Boleh faham? Simple kan? Can you understand this one? GMP. Blueprint. Okay, nama lain dia kadang-kadang kamu akan dengar benda ni. Blueprint. Maksudnya, dia adalah satu peta. Okay, so this is the peta, the GMP. And this peta being made for every single class of action. So if you, let's say we have 20,000 class of action, we have 20,000 GMP in our mind. Dalam 20,000 tu, there will be subfolders. Okay, which divide that action into several direction. Contoh, jogging forward and jogging sideways. The difference is just the direction. Stride length going to be similar. Speed is going to be similar. So, the direction is part of the parameter. Kita akan ada satu lagi parameter dekat bawah. Direction of action. D1, straight. D2, left. D3, right. D4, back jog. Contoh begitulah. This is how GMP works. How Smith schemata works. Okay, based on ni, Smith schemata. A class of action contain invariant features and parameters. Invariant are fixed and do not vary. Parameters is the thing that have the variant, have change. So this is based on motor program based theory ataupun Smith generalized motor program. Smith GMP. Nama dia banyak, nama dia beza-beza sama je. Kat sini we have Smith GMP, kat depan ni kan nampak Smith schemata pula. Okay, schema is blueprint. Okay, this is a blueprint. Okay, sampai sini dulu. Can you understand? Movement in term of folders. Nak movement A, ambil folder A. Nak movement B, ambil folder B. And so on. Okay, itu based on Smith schemata. Means that we have a lot of schema in our mind. We have a lot of schema in our mind. Okay, this is the first theory. This is some empirical support, investigate relative timing invariant across different duration. Walk and run study is consistent with the hypothesis of relative timing. Pattern tak berubah, but the speed change. Okay, so nampak, within ni kita kena buat eksperimen lah. Berjalan dengan berlari, Within each gate pattern, relative timing is maintained but the duration parameter differ. Okay, lawan dia, they come up or they propose another theory known as dynamic pattern. Okay, Smith schemata or the GMP said that if you try to do this, you have GMP A. If you try to do that, you have GMP B. So every single time when we try to conduct different action, we need to load more GMPs, not based on dynamic pattern. Okay, so GMP tadi, it being store one class of action in term of invariant features, in term of parameter. Okay, so dynamic pattern theory pula cerita describe the control of coordinated movement, emphasize the role of information in the environment and dynamic properties of the body. This is more towards a closed loop. Okay, this is more towards a closed loop. Yang tadi more towards an open. Interested in how a system change over time due to influence of particular variable. Okay, based on dynamic pattern theory, kita buat eksperimen simple ni sekejap. Okay, I need you to do something like this. Okay, bring out your arm. Macam ni. Okay. Kita akan ada dua fasa. Fasa ke dalam, this is known as in phase. Cuba satu-satu jari. Okay. Jadi dia pun sama. Kalau ke dalam, this is known as in phase. Kalau keluar, this is known as out phase. Jadi kita ada in phase, out phase. In phase, out phase. Okay, ini dua fasa dia. Okay, now, try to move like this. One hand, move in phase. Another hand, move out phase. So, dia akan jadi macam ni. Jangan letak kat dahi, nanti jadi macam loser pula. Kat depan. Okay. Kita nak dia berlawan. Okay. Satu in, satu out. Satu in, satu out. Now, try to do this. Try to speed things up. And I need you, I observe your hand. Try to notice at one point, it is not going to be in out lagi. Dia akan jadi macam ni. In phase, out phase. In phase, out phase. In phase, out phase.
Betul.
Okay, mula-mula macam ni kan. Laju lama-lama dah jadi macam ni. Ini apa yang diceritakan oleh dynamic pattern theory. It said that our body will try to revert back to its condition where it is much more stable. So by having one hand in, one hand out, this is not a stable condition. The stable condition is that for both of peripheral to work in the same direction. If right hand do an in phase, left hand will follow. Ini stable condition kita. Ini bukan stable condition kita. We can do this but not that much. Dia akan revert to stable condition. This is what being taught by dynamic pattern theory. Okay, inilah yang dikatakan oleh dynamic pattern theory. So what caused the change? What caused the change? Okay, that cause is the basis concept of dynamic pattern theory. And in this experiment, the cause is actually the speed. Speed. Okay, kalau kita buat perlahan-perlahan, so okay, speed things up. They are going to change. So speed is one of the parameters determine the movement itself. Okay, now we revert back. We revert back to our condition here. Condition of jogging versus walking. Okay, now we are going to add on another one. Running. These three distinct action came from the same class, locomotion, but it has different parameters. Satu, stride length difference. Dua, speed difference. Apa lagi satu tadi? Stride length differ. Lift up. Okay, lift up of the knee is different between these three things. Okay. Next, my question. Katalah kita ambil running, kita ambil dua dulu. Kita ambil running versus walking. Okay. If you walk, how about your hand gesture? Macam mana bentuk tangan kamu bila kamu berjalan? Are you going to swing the hand as you running, or it will be placed at your side and just have a bit of swing? Macam mana keadaan tangan kamu? Swing high, small swing. Walking.
Swing high.
Walking, swing high. Swing. Is it?
No.
Running, swing high.
Yes.
Small swing. Okay. Now, imagine this. You are walking. You are walking. Okay. Walk at the park, and suddenly you see you see a dog. The dog is charging towards you. What are you going to do? Tengah jalan makan angin, kan? Girlfriend kat sebelah, tengah pegang air jagung. Anjing kejar. Laju gila anjing tu dia. Kamu tengok pakai mata sebelah. Ui, anjing kejar. What are you going to do?
Lari.
Kau tinggal girlfriend kau.
Ajak dia lari.
Nasib dia lah
Kejar
kan
dia
satu
balik.
lembab kan.
Betul tu Sah. Tinggalkan je.
Okay. Lari. Now my question. Now you are running. Means you have changed walking gait to running. My question. Tangan kamu automatically hayun ke masih duduk kat tepi?
Auto hayun.
Auto
hayun.
hayun. That is what meaning of dynamic. Meaning that when parameters being changed, our body will automatically change to the much suitable pattern of movement. Bukan lagi kita load. Okay, bukan lagi kita load. Instead, it change according to the speed. Kalau kat sini lah, the thing that plays here is actually the speed. It determine if the speed is low, you're going to be walking. If the speed is high, you're going to be running. So if you are walking, gait of walking will be followed because by low speed, that is the preferable action. Tangan dekat tepi. Tak ada orang nak jalan kan, tangan hayun. Beria ni tangan hayun. Kaki slow kan. Tak ada. You cannot do that. You cannot, orang kata, saya nak cakap lumrah ni bukan begitu. Dia action is not like that. If you hayun tangan laju-laju, automatically kaki kamu akan laju. Automatically. Same goes when you start speed up your movement of the leg. Automatically your hand is going to swing. Automatically. Because that is the stable condition. So our body, the coordination of our body, try to be as stable as possible according to the condition. So the condition being determined by parameters. By parameters. One of it is speed lah kat sini. We change the speed. Now the gait of walking change to gait of running. Katalah awak dah lompat longkang, you know that the longkang is very big. Okay, lompat lepas and you know that the anjing cannot lompat. Automatically after lompat longkang, you stop the running phase. Means you slow down. So tangan kamu yang berhayun ni bila slow down, it will automatically turun and duduk dekat sisi. That is the change. And this change caused by several factors. Kita akan tengok depan nantilah. Caused by several factors. You just need to bear in mind, our body will start to coordinate based on stability. Bukan stability berdiri tau, but the stability of the action. There are certain stability since one of it is speed. So kalau laju, macam mana keadaan tangan? Kalau perlahan, macam mana keadaan tangan? It will automatically being adjust like that. That is what dynamic pattern theory said so. Bukan lagi nak load satu JMP, load another JMP untuk running, load another JMP for walking, no. But it said that control of coordinated movement, emphasis on the role of information of the environment. So, it is interested on how the system change over time due to influence of particular variable. Okay, now imagine this. You play soccer. Okay, you play soccer. Dulu sepak tonjol. Okay, dulu sepak tonjol. Pasal pada fikiran kamu, doing so the ball is going to travel as fast as possible. But eventually you notice that doing sepak tonjol, the ball is not that fast. The kaki is hurt. Okay, the kaki is hurt. And if you go with a proper kicking technique, the ball can travel much faster. Okay. Now, when you try to kick a ball, automatically your leg is going to not switch side. It's going to calculate where is the best possible place to do a contact based on ball speed. Kalau bola ni laju, kat mana kita nak contact? Kat mana kita nak hayun? That is dynamic pattern theory. Okay, that is dynamic pattern theory. And the relation with the previous one, the GMP, is about the modification. So when a kick being contact and the outcome is preferable, new GMP will be made and stopped. Nampak tak dia punya kaitan? Okay, new GMP will be stopped. So that in future when you try to kick a ball as similar as the one that you do today, you have the GMP to do so. So tu saya kata dia ada kaitan. Although the theory said differently. First theory said that one movement, one GMP. Second theory said that our movement being altered accordingly to the information that we have, accordingly to the stable condition. Itu dynamic pattern theory. Meaning that running tadi ada satu je running GMP dia. Tapi macam mana kita nak ubah running jadi walking? We change the speed. And automatically the gait for walking will be follow. Because that is the stable state. Okay. Dapat tak sampai situ? Dapat tangkap?
Okay, sir, boleh.
Boleh. Okay, boleh. Okay. Alright. So this is some of the properties for dynamic pattern theory. The first one is stability. Stability refer to behavior, steady state of system. When the system is perturbed, it will return spontaneously to a stable state. Contoh, kalau kita berdiri dua kaki dengan kita berdiri satu kaki, mana lagi stable? Dua kaki. Jadi, in any condition occurs if our body sense that it lost stability. Dua kaki akan turun automatically. Okay, bila kamu jatuh, contohlah orang tolak kamu daripada belakang, first thing apa yang kamu buat? Orang tolak pada belakang. Zaz, what are you going to do?
Try untuk balancekan balik.
Try untuk balancekan badan. First mesti orang keluar tangan. Automatically tangan akan keluar. Okay.
Terbang.
Tak ada lagi orang tolak belakang, tangan tak dalam poket kan. Orang tolak tangan duduk dalam poket, molek tumbang ke depan. Tak ada. Tak ada. Because stability of that particular gate is actually untuk control COG. Itu maksud stability. Sama macam ni. This is not stable. This is stable. Means that a state where the body is at dia punya orang kata macam ni, steady state dia. Steady state dia. So kalau kata kita berlari dengan berjalan. Okay, if we compare lari dengan jalan, which is much more stable? Our steady state. Are we being made to run or are we being made to walk? Kita ni direka untuk sentiasa berlari ke berjalan? Yang mana satu?
Berjalan.
Jalan. Jadi cuba kamu berlari. At any given point of time, berlari, tak tentu arah. Your body will actually try to be jalan. Okay. Niat di hati hilang je sekejap lagi, dia automatic dia akan berjalan. Because that is our body behavior steady state. Itu maksud stability. Okay, that is our stability. But if we go for practice, you're going to notice that jogging become normal. And then running become normal. Asal terbuka pintu je keluar confirm lagi. Tu dah jadi stability state baru. Dia dekat running. So that at any given point of time, your body try to remain on that pace. Pasal coordination on that pace is the much steadier compared to others. Tu maksud stability. Number 2 is attractors. Okay, under dynamic pattern, we have attractors. Refer to stable behavioral steady state of system. Prefer behavioral state. Energy efficient state, meaning that at any given point of time, contoh macam lari dengan jalan tadi, arm swing. Okay, kenapa we cannot walk with like this? Jalan ni, tak macam ni. Jangan bayangkan orang panggil kau gila lah. Don't imagine that. Just imagine why we cannot run like this, just hand at the side, tapi running laju gila. Or why we cannot walk like this. Jalan setapak, tangan ayun, satu tapak tangan 4 kali. Oh, jalan. Kenapa tak boleh buat? Kenapa kamu akan rasa macam penat dia buat benda ni? Okay, you're going to feel like that because that is not attracting. When the leg is fast, the hand is going to follow. That is attractors. When the hand is fast, automatically the leg is going to follow. And if the attraction occurs, you're going to feel the movement is quite easy to move. You're not going to feel burden, such as walking slowly and ayun tangan kuat-kuat. That is not stable, and the movement of the hand and leg is not attracting to one another. Ni dua benda dia. Okay, stability and attractors. Okay, next one we have. Ni dia bagi contoh tadi lah. Okay, contoh yang sama. We have order parameter and control parameter. Okay, order parameter and control parameter ni, you can imagine it quite similar as invariant dengan parameter. Okay, so order parameter also known as collective variable, functional, specific and abstract variable that define the overall behavior, enable a coordinated pattern of movement that can be reproduced and distinguished. Relative phase is the most prominent of order parameter, which represent the movement relation. Control parameter, variable that when changed will influence the stability and character of the order parameter. Okay, order parameter ni maksudnya macam ni. We take hand and leg tadi. Okay, we take hand and leg. Okay, hand and leg. So, in order to walk, order parameter said that your hand need to be, the coordination of the hand need to be at side. Satu. Yang kedua, the speed of the swing need to be, apa tu? Need to be similar as the speed of leg swing. Tu order parameter. Control parameter is the variable that change this one. Contoh, we speed up the leg. Automatically tangan akan laju. Tu control parameter. Okay, tu control parameter. Okay, ataupun macam ni, kamu tengah berenang, you do freestyle. Semua orang boleh berenang, tahu berenang, tak boleh berenang tak apa. You know swimming?
Yes.
Tahu.
Freestyle, tak kisahlah freestyle yang jenis ambil nafas 5 stroke ke ataupun freestyle kampung, kiri kanan, regardless. Bila kamu buat freestyle, kaki macam mana?
Bicycle kick kat belakang.
Yes.
Bicycle kick. Okay, bila kita buat breaststroke, kaki macam mana?
Kuat.
Kuat kan?
Kata.
Yes.
Kata, yes.
Kaki will move like the frog.
Triangle.
Apa dia?
Yes, terbuka. Dia macam terbuka and then
Ah,
tunjuk balik.
macam katak. Okay, the leg
Macam
movement
cicak.
macam cicak lah, tak kau lah macam cicak ke macam katak ke. But there are difference between cicak, katak and basikal tadi. Okay, cicak, katak is a group, basikal satu group. Okay, do you ever try to do freestyle stroke tapi cicak kick?
Tak pergi sir.
Pernah try tak? Rasa dia macam mana? Saya nak tahu dia rasa dia. Syahdu
Boleh
tak?
try ni.
Boleh lah try atas-atas. Cuba try. You go freestyle, at the same time the leg kicking like breaststroke. Ataupun you do breaststroke but the leg flutter.
Dia akan satu tempat je.
Dia bergerak, jangan risau, dia bergerak. Tapi kau akan rasa janggal gila. You're going to feel very, very weird doing so because it is not stable. The movement is not attract to one another. Okay, itu maksud attractors and stability. So order parameter is like that. Freestyle, the leg will be fluttering kick. That is dia punya coordination. Okay, coordination. Breaststroke is katak kick. Okay, katak kick or cicak kick. Control parameter here is pattern. If you go right hand and left hand, automatically kaki akan buat flutter. Order dia macam tu. Control dia, the sequence. But if you go both hand at same time, automatically kaki kamu akan tukar kepada katak kick. Okay. So the change caused by control parameter. The action being determined earlier by order parameter. Tu order dengan control parameter. Okay, order parameter coordination yang kita dah buat. Control parameter, the parameter that change this order. Okay, macam lari tadi, the speed lah. The speed change the order. If you go low speed, control parameter say that we're going too slow, coordination akan jadi berjalan. Order parameter. But if the speed being increased, automatically order parameter will enable running, because that is the much stable condition on that particular moment. Tu order parameter dengan control parameter. Okay, and then our body have self-organization. When certain condition characterize a situation, specific pattern of limb movement emerge. Coordination pattern of movement self-organized within the character of environment condition and limb dynamic rather than a motor program. Okay, based on self-organization ni, kita tengok balik benda ni sebenarnya. Order parameter ni. Berenang tadi. Okay, berenang tadi. Kenapa lah kita tak boleh nak buat free stroke, freestyle dengan katak kick. Ataupun nak buat freestyle kaki kaki dolphin. Macam butterfly. Okay, butterfly, kaki dolphin. Okay, kalau kita buat front crawl, kaki kata. It is not due to the fact that that is the skill, but that is actually when you learn the skill, that is actually the stable state. Okay, jadi automatic lah kita tak payah buat both hand. Okay, freestyle both hand, we just do one hand. Although it is just one hand, but your body will self-organize. It will determine this is a stroke of free. Kaki automatic flutter kalau kamu. Dua tangan pun flutter, satu tangan pun flutter, because the model said that this is a model of freestyle. So other part of the body will self-organize to accommodate that particular style. Kenapa dia self-organize? Ini. Stability and attractors. Okay. And last one is coordinative structure. Skill, action, result when specific synergies of the muscle and joint act cooperatively so the person can carry out an action. Coordinative structure can be innate or learned. Okay, coordinative structure ni will start with learning process dulu. Contoh, kita belajar front crawl, flutter kick. Mungkin at one part of the world, they learn front crawl, okay, and flutter kick. They learn about that. If that is the coordinative structure, automatically, when you execute that crawl, kaki akan flutter, because that is the coordinative structure being stored in terms of your GMP. Ni cerita dynamic pattern. Okay, so the difference before we stop, we are going to stop and have a rest. Afterwards kita akan sambung satu topik pendek je. Okay, based on what we have learned today, Smith schemata, the generalized motor program, said that every single class of action have 1 GMP. Swimming, 1 GMP. Underneath swimming, kita ada IV dia, means move forward. Invariant features, IF. Okay, the hand need to always move forward. Benda yang sama. Benda yang tak sama, there will be parameters such as one is free, one is crawl, another one is butterfly. Tu based on Smith schema. So if you go with butterfly file will be load. But based on dynamic pattern, it said that our body try to be as stable as possible. Okay, so if the parameter being changed, if the order parameter being changed, and not order, the control parameter being changed, automatically a new order will be load. New order will be follow, because our body self-organized, and they try to have an attraction to be stable. Bukan ada banyak GMP nak keluar, but only one GMP. It is based on the attraction. Kalau kaki laju macam ni, automatic tangan akan follow laju macam tu. Itu dynamic pattern, and that's the reason the name is dynamic pattern theory. Means that the pattern itself change accordingly to the situation. Generalized motor program, every single motor program have one folder or one GMP or one blueprint in order for us to load and execute. This is two theory based on open loop system and closed loop system. Okay, so that's all for our first part of the class. So we are going to take a break. We are going to meet again. Okay, in this topic, we're just going to touch two things. First one is Fitts law, and number two is a prehension. Okay, so this topic I discuss a bit about performance character of a complex skill, meaning that when we able to coordinate and have a good degree of freedom, this is some things that you may see based on the performance. Okay, so the concept of this topic is specific character of the performance of various motor skill provide the basis for much of our understanding of motor control. And the performance in particular is actually apprehension. Tu je satu performance yang kita akan bincangkan sebenarnya. Okay, so when we talk about apprehension, apprehension is a process of manipulation object, grasping. Okay, move towards grasping and manipulation. Maksudnya penggunaan tangan, memegang, menggenggam. That is apprehension. And when we talk about apprehension, the concept or the term that play in mind is actually speed, accuracy, skill. Whether we are going to speed or whether we are going for accuracy. It cannot have both. If we go for accuracy, the speed is going to be slowed down. If we go for speed, the accuracy will be reduced. Okay, so when both speed and accuracy are essential to perform a skill, you are going to have a trade-off. Satu naik, satu turun. Satu naik, satu turun. Okay, macam tu. Alright. So this is based on Fitts law. Based on Paul Fitts, it predict that movement time for a situation require both speed and accuracy is in a negative relation. When we increase one, another one will drop down. Itu dia punya prediction lah. Okay, and it being proved that we cannot have both. For example, let's say we try to throw a dart. Okay, we try to throw that dart as fast as possible. So the time for aiming will be lesser. Means you are going to sacrifice accuracy. But if you take time for to get an accurate shot, it takes a longer period of time. Means the speed is being neglected. This speed accuracy trade-off. Okay. So and then and this speed accuracy trade-off. So this is the general agreement about motor skill process. If we go for open loop control, okay, means the control without any feedback needed. Movement initiation instruction is sufficient to move the lead. Means kita ambil dart throw dia kan. We focus on throwing a dart and we execute regardless of angle, direction. So we just use whatever information we have in our mind to throw. Okay, if the first throw does not reach the target, and then only we go for closed loop. Means now we have aiming. Accuracy is going to increase. Adjustment is going to be made based on the first throw, but it takes time. Speed and accuracy. Okay, when we talk about speed, most of the time it use closed loop. It use open loop. But when we talk about accuracy, it use closed loop. Speed use open loop. Benda yang dah ada, how to throw, dia ada dah kat situ. Reload, balik. Kena tak kena lain cerita. But if we try to aim, and then the focus is accuracy. So you're going to take more time because closed loop says there are presence of feedback, so it takes time for computation. Ini speed accuracy trade-off. Okay, and the most common way for us to determine speed accuracy trade-off is by an action known as prehension. So prehension ni menggenggam. Saya suka namakan dia sebagai manipulation. Okay, how we manipulate object. So in order for us to manipulate this object, we need to go to the object. That is the first one, transport, movement of the hand to the object. Second one is grasping, take the object. Okay, and finally, manipulating, use the object. So these three phases, these three components make an action known as prehension. Okay, move to, grasping, manipulating. Okay, two term dia. Alright, and then relationship of the prehension component of these three. The reach and grasp are not two separate movement components, but interdependent. Visual information and intended manipulation of the object, the system to initiate the reach and grasp as well as influence visual feedback. Okay, apa kaitan prehension ni tadi dengan speed accuracy trade-off? Now, let's imagine this. Just put your pencil anywhere on the table. Okay, anywhere on the table. Now I need you to just use two fingers, try to reach and pick the pencil. Okay, at a spot. Contoh macam ni tempat pegang ni kan. So I need you to go pick and hold. Okay, tiga benda. Pick and hold. Now change the place of the pencil. Letak tempat lain. Again, go pick and hold. Put another place, again, go, pick, and hold. You're going to notice that from every single trial, the time taken is going to be less and less and less. Means it becomes faster and faster. The first time you go pick and hold, it train your accuracy. And when the accuracy is there, we can increase the action speed. Okay, however, kita tak boleh dapat dua-dua lah. Kalau kata kita nak cepat, janganlah pick pakai benda ni, pick lah pakai semua sekali, kan lagi cepat. But in terms of accuracy, it's not there. To speed accuracy trade-off based on prehension. And to do a good prehension, we need one other sensory beside kinesthetic. We need our we need our vision. Penglihatan, penglihatan. It helps a lot. Okay, so vision in prehension play some roles in several phases. The first one, at the preparation of the phase, where we are going to assess regulatory condition. Means we are going to assess size of the object. We are going to assess the distance of the object. We are going to assess the shape of the object. So that we can make our mind where we are going to grasp. Okay, number two, in the process of transporting. Tadi, preparation of action. Now, process of transport. By using our eyes, it helps a lot in determining the spatial and temporal. It helps you in determining the reach. Now, let's do the same experiment. Okay, with the same pencil. Put on the table. Close your eyes and try to reach that. Okay, put in the table, close your eye and try to reach that. Okay, senang, jangan risau, senang. Now, number two. Use your left hand. Okay, close your eyes. Now close your eyes first. With your left hand, put the pencil anywhere else on the table. Without opening your eyes, by using your right hand, pick it up. It takes a bit of time. Okay, dia tak sama dengan tangan kanan yang letak tangan kanan yang cari. It takes a bit of time since it involves different peripheral. The integral line is not there. Okay, again kita cuba lagi sekali. Dah ada pencil kan? Now put your pencil anywhere with your right hand. Close your eyes. Close your eyes first and then put it anywhere. And with the same hand, pick it up. You're going to notice it is going to be much easier compared to the left hand put pencil. Okay, simply because it is on the same peripheral. Ini muscle memory. This is what we know as muscle memory, temporal and spatial arrangement, because our muscles remember how much length it goes, how high it goes, how wide it goes. So it's going to be much easier. Banding dengan buka mata memang lagi mudah lah. We are not relying on spatial and temporal, and at the same time we rely on visual. Okay, and finally during the grasping process, Vision supplement the tactile. Supplement, okay, the tactile and proprioceptive. Mean during grasping, kita akan lebih accurate by having vision. We can have the accuracy without vision, but it is much more accurate with help of vision. Now we have vision and kinesthetic to determine the accuracy. So here we are, we know that by having a role of vision, it helps us to increase the speed and accuracy trade-off. Okay. Ni contoh handwriting. Okay. Now, okay, kita akan cuba satu benda yang sama kita pernah cuba tadi. Ini semua benda yang sama lah. Okay, kita akan cuba benda yang sama dengan benda yang kita cuba tadi. Do you still remember cross and square and circle? We are going to try symmetric by manual coordination and asymmetric by manual coordination. So to do so, you need to have two pencil. Bukan satu lagi, but two pencil. Okay. Draw the cross first. Those 8 Cartesian coordinate, buat itu dulu. Okay. Buat benda yang sama ni dulu. Okay. 4 di sebelah kanan, 4 di sebelah kiri in one A4 paper. Settle? Settle tak? Settle bagi tahu.
Settle.
Okay, now by using two pencil. Satu di sebelah kanan, we start with the first line. Satu di sebelah kanan, satu di sebelah kiri. In the first box, I need you to draw a square. Both hand draw a square. Tak kisahlah ke kiri ke kanan, but I need to have a square there. Silakan. Settle bagi tahu. Square. Square. Settle?
Okay, sir. Walaupun tak menjadi.
Tak menjadi. Mana tengok gambar kotak? Cuba siapa-siapa share gambar kotak dia. Kotak yang pertama. Kotak dan si petak-petak. Can somebody share? Ada pun kotak. Come on lah, bagi gambar kotak. What happened to the kotak? I want to see the kotak.
Kotak ni buat tangan mana sir?
Tangan kiri dan kanan dua-dua buat kotak. Ke arah mana tidak mengapa. Janji kotak. Tu. Nabil tak nampak Nabil dia background. Saya nampak. Okay. Alright. Okay. Kotak, Cartesian coordinate yang kedua, second line, I need you to draw circle. Both hand drawing circle. Kiri dan kanan sekaligus. Circle. And then please show your circle. Yang kita tengok dia jadi circle ke, dia jadi egg ke. Circle. Okay. That is what we call as symmetric, where by using different peripheral, we do the same action. Mesti kamu buat tu kalau tangan kanan pergi kanan dulu, tangan kiri pun akan pergi kanan dulu. Dia takkan pergi tangan kiri terbalik. That is called symmetric. Now let's try asymmetric. Okay. On the third column, with your right hand, please draw a square. With your left hand, please draw a circle. Kiri circle, kanan square. Sekarang.
Susah sir.
Memang
Confused.
lah, takkan senang. Tak apa, buat je. Tengok, biar je apa jadi. It's okay. Tangan kanan square, tangan kiri square. Kejap Nabil, kejap Faris. Kiri sini. Mana Faris? Tengok balik. Okay. So Faris ada separuh circle, separuh square.
Yes. Yang circle tu dah macam square dah saya tengok.
Nabil. Rapat sikit Nabil, saya nampak ni je, nampak background ni. Kertas kamu jadi background. Tak nampak Nabil. Okay. Sama macam Faris. Sequeller. Susah nak sebut. Okay, now we change side. The right hand is going to draw a circle. The left hand is going to draw a square. Kita tengok apa hasil dia. Faris. Tengok Faris. Jangan
Lebih
kata sama
kurang
macam
yang
tadi.
ni. Lebih kurang je. Tapi yang ni ke arah circle lah orang kata.
Okay, alright. So, I need you to notice things between the third row and the fourth row. You are going to notice that certain hand able to conduct it better compared to others. Okay. Certain hand. Although the shape is actually similar shape, circle and square, but one hand able to draw circle just like a square, but another hand able to show the shape. Okay, ni maksudnya you have the ability to do asymmetric bimanual coordination. Meaning, when we do symmetric coordination, symmetric bimanual coordination, means that regardless of which hand we start drawing the shape, you are going to end up with similar outcome. But for asymmetric means that if we train on one peripheral, the outcome will be different if we train compared to others. Contoh macam si Faris tadi, kalau kita buat circle dekat tangan kiri, it's going to be square. But if we go for the right hand, it's going to be much secular lah compared to the left hand. Meaning, the transfer of learning from right hand Faris is much better compared to the transfer of learning from left hand. This is asymmetric bimanual coordination. Boleh try lah. Lama-lama kamu akan dapat rhythm dia and you can actually draw quite similar with both left and right. Tu adalah bimanual coordination. And if you try to have it better now, if you try to have a better outcome now, try to do square and circle on different hand, but take your time. Atau speed accuracy trade-off. Tadi you try to have that in quite a fast manner. Now, cuba buat circle and square slowly. Okay, slowly. Focus on the accuracies rather than the speed. This is speed and accuracy trade-off occurs in prehension. You're going to notice that after a number of trial, it's going to be better and better.